And we're going to share the screen. We're going to move this over here. What else do we have? Let's go back to hours for QuickTime. QuickTime, it's week 3. This one, right? Let's open this up so we can go where we left off. I need you to do your thing. Come on. Unplug you. All right, let's see what happens this time. Okay, that's what we want. All right, start here. I think this is us. So let me add a page. Okay. So we got read at about an hour. That's about an average. That's about how we do each time. Okay. Did I miss anybody? Is anybody on the call that feels like they did not get attendance credit today? Okay. I think we got everybody. Oh, let me go ahead and do the following. Security. We started at 5:15, so let's go to, we're going to lock the meeting, and we're going to enable the waiting room. Okay. I think that's fine. I'm not going to worry about that. Let's go here. We're going to open up the chat so we can monitor the chat. All right. So let's go ahead and show the iPad. And so last time on Dragon Ball Z, totally sleepy. I think one of the last things we talked about was finding the range of a function. So I think we worked through this example. Okay. So we're going to pick up from there. So today is September 3rd. So we're just going to start from here. Is this the right one? Yeah, this is the right one. Okay. New single page, and we left off here. Okay. Okay, so we'll start here today. So we're going to close out section 1.3 today. I think this is section 1.3 on functions. And so we have this notion of what we call as the vertical line test. So last time we said that given a relation, if we have repeating x's, then we say that it's not a function. So in a graphical sense, repeating x's appears like this, where if we can draw a vertical line and it touches the graph more than once, then we say that that's not a function. Okay, if we can draw a vertical line and it touches the graph more than once, then we say it's not a function. All right, so this is an example of a graph that's not a function. So what about this one? Is this a function, yay or nay? Is this a function, yay or nay? So let's draw a vertical line, right? We got a vertical line. Let's go like this. I'm gonna go about this thickness. Let's go. So let's see. No matter, let's see, it touches it once there, once there, once. But if we draw the vertical line here, it touches twice, right? So this is not a function.
Not a function.
Okay. Is this one a function, yay or nay?
Nay.
Not a function, right? We can draw a vertical line that touches it more than once. What about this one, yay or nay?
Yes.
Yep. No matter where we draw a vertical line, it only touches the graph once. And keep in mind, these arrows mean continue the pattern. So like this is going to continue in this direction just forever like that. This continues in this direction forever like that. Okay. So the arrows mean continue the pattern forever. And this one does pass the vertical line test, so it is a function. Is this a function, yes or no?
Yes.
Yes, right? Okay. So yeah, no matter where we draw a vertical line, it only touches the graph once. Okay, so then we have this example on examining the graph of a function. Let f of x be this part here. I'm going to need some paper. So let me get a copy. I don't need that. Ooh, delete. And I'm going to crop this. Oh, and let's go ahead and copy. Come on. And I want to add a page right here. You can drop right there. Okay, that's good. Oh no, undo. All right, and then paper, graphic. All right, view, seamless. Okay. So we're gonna let f of x be this. Question A says, is this a point on the graph? Okay. So let's start by getting a copy of the original. We have this f of x equals x squared minus 2x minus 3, right? Question A asks, is the point 1 comma negative 3, is it on the graph? So in order for 1 negative 3 to be on the graph, basically what it's saying is that when x is 1, so when x is 1, y should be negative 3. So what we're going to do, first I'm going to replace each x with a blank set of parentheses to do my substitution. Then, again, the number in question for this goal is when x is 1. Let me do something really quick. Okay, so we're plugging a 1 into each of these. Okay? So then, we continue. 1 squared is 1. Minus 2 minus 3. That answer is, what, negative 4. Notice that negative 4 is not equal to negative 3. Right? So the answer will be no here. So as we kind of go through these examples, if you have questions, I am monitoring the chat. You can either type your question into the chat, or you can just unmute yourself and ask your question. But I will be periodically checking the chat and answering questions there. Let's go to, let me add some paper. And let's go on to part B. B says, find out values of x such that x comma 5 is on the graph. So we want to check x comma 5, right? So basically this is saying when y is 5, what values of x will produce an output of 5, right? So we're going to basically set y equal to 5. So we have this x squared minus 2x minus 3. We want to set that equal to 5 and solve. So then we'll get x squared minus 2x minus 8 equals 0. We just subtracted 5 on both sides. Can somebody tell me, what is this technique called that I'm doing here? What is this called? It begins with an F. Factoring, right? We want to factor. So we have a trinomial. We set it equal to 0. Anybody feel confident in walking me through this factoring?
I'll do it.
Go ahead.
Okay. So what I do like the little X thing, you know? So you gotta have two numbers that multiply the negative 2 and add to negative 8, correct?
Okay, you said X like this?
Yeah.
Okay.
And then you put the top and negative 8 on the bottom.
You said negative 2 on top?
Yeah, negative 8 on the bottom.
Okay.
And you gotta find two numbers that multiply negative 2 and add to negative 8.
So two numbers that multiply to give us negative 2 and add to give us negative 8. What are they?
Let's see. Maybe it's the other way around.
Yeah, I think it's the other way around.
What's the other way?
It's negative 8 at the top and negative 2 is at the bottom.
Okay. You said negative 8 on top and negative 2 on bottom.
It's 4 and 2. Negative 4 and positive 2.
I'm trying to see this method though. I've had students use this method in the past, and I don't know why it's not sinking in this time.
Negative 4, positive 2.
Okay, but you got the idea, right? Let me get rid of this because that's not a fully developed idea. But yeah, we're looking for two numbers that multiply to give us -8 and add to give us -2. And I think it's what? -4 and a positive 2?
Yes.
So we said -4 and a positive 2. Let's see. -4 times a positive 2 is indeed a -8. -4 plus positive 2 is indeed -2. Okay. So that looks good. So now we can use what's called the zero factor property. When we have two or more things that multiply to give us 0, basically we set each thing to 0 and solve. So we're going to have this x minus 4 equals 0, or x plus 2 equals 0. From here, we get what? X equals 4, or x equals a -2, right? What are we saying with these numbers? Oh, so we're saying that if x is -2 or 4, they should produce an output of 5, right? We're going to check these at the end before we look at the answers. Okay. Let's go into part C. Oh, part C and D. C is find the y-intercepts, and D is the x-intercepts. So for the y-intercept, how do we find the y-intercept? We set How do we find the y-intercept?
Set x equal to 0.
For that question, I see a question that says that means that it's not a function. Is that about this or one of the previous examples from Mr. Timothy Taylor? We're going to set x equal to 0, right? So let me get a copy of the original, which is here. So then if we do f of 0, we're going to have 0 squared, previous, okay, thanks. 0 squared minus 2 times 0, minus 3. And you should see, it should be quick that this goes to 0, this goes to 0, and this is our answer. Okay. So the y-intercept, we can say 0, -3, or just -3. That works too for this context. Ooh. Let's go like this. All right, and then D, we want to find the x-intercepts. So we're going to set y equal to 0. Have some water. So if we set y equal to 0, we're going to have x squared minus 2x minus 3 equal to 0. Okay, so we want to use a similar technique. We're going to factor. We got our x and our x. We're looking for two numbers that multiply to give us -3 and add to give us -2. I think that's okay. And this tells us that the larger number is negative. So it's going to be a -3 and a +1, right? We're just about out of water. We're going to replace you. Hey, I'm recording. Can you cut that out? Thank you. Come here. Come here. I'm recording right now. Do you mind? You want to say hi? Come on.
I thought he was talking to one of us.
No. She's up here like screaming in the background because she hears like something moving out there, and she don't. So she just wanted some attention now. So she just waking up. So she's like, "Hey, give me some attention. Go ahead. Well, please, I'm trying to record. Just relax for like, give me like 40 minutes. Can you like lay down for like 40 more minutes?" She's like, "Okay." Okay, anyway. So then we set each one to 0 and solve. Ultimately, we get x equals 3 or x equals, I think it's a -1. Okay? So we're saying these are the X-intercepts. So we're going to do 3, 0, or negative 1, 0. Okay. So then we can actually check a lot of these. Let's undo that and do that a little bit better. Awesome sauce. Style, let's go thickums like that. That looks better. Okay. And let's go paper, get rid of this. And let's check these results, right? So we got A, B, C. We want to check. I know it's a little bit small, but we're just doing this so that we can check. So now I'm going to call on my trusty dusty rusty like this. All right, my calculator. As soon as it loads, come on. Try that one more time. Nope. Okay, that looks good. Okay, so the original is, I'm going to go y equals, the original is x squared minus 2x minus 3, right? I'm going to quit. And then right here, so right here you see the clear button. To the left of the clear button is VARS. I'm going to click on this button right here where the cursor is. Okay, I'm going to click there. So if I click variables, I'm going to go to the right to go to y variables. I'm going to hit number 1 for function, and I'm going to hit number 1 again to call in the function I just typed in. So again, when x was 1, we got an answer of -4, which is not -3, so we confirmed that one. For B, we said when x was -2 or when x was 4, we got 5. So if we plug in -2, we should get 5. Whoop, I didn't type in -2. If we type in -2, we should get 5. And if we type in 4, we should get 5. Okay, so we confirmed B. C, we said when x is 0, we said that y was -3. We got that one. And for D, we said when x was 3, we got 0. And when x is -1, we got 0. Okay, so we confirmed all our results. So again, what we did, we typed it into the y equals, and then we used this variable function right here to the left of the clear button to call on the function that we had just typed in. Okay. Let me see. What is the difference between a bracket and a parentheses? Can somebody explain the difference? So not in this case. In this case, the parentheses just mean an ordered pair. It is contextual. It is based on context. I know we've been using parentheses for this example, but in this context, parentheses is used to describe an ordered pair, like a point on an XY plane. But in other contexts, like if we're talking about an interval, can somebody explain what's the difference between parentheses and a square bracket when we're on an interval? So if we're talking about an interval, parentheses means, go ahead. So there's a shortcut if you want to unmute yourself. If you're on a laptop, you can actually hold the space bar, and it should unmute you only while you're holding the space bar.
You can hear me?
Yes.
Okay. So parentheses is used when like the point or value is not included in the interval, and the bracket is when it is included.
That's pretty good, right? That's pretty much it. Parentheses means we get really close to that number, but we do not include that number. And parentheses bracket means we get really close to the number, and we do include the number, right? So parentheses, we don't include the number. Brackets, we do include the number. But in this context, we're using parentheses as like to group the ordered pairs, the x, y. But when we're talking about intervals, that's how the discussion goes. These are good questions. Okay, let me switch this back to single page. Okay, I feel good about this stuff. So I think we got no for number 1. I think we got the 4 and the -2. We only got the 1 y-intercept of -3. And we got these 2 x-intercepts. Let me see the time. I gotta stop watching the clock. That's totally making it slow down. I'm like, the dog was just here. We had 40 minutes ago, 10 minutes ago, and somehow we still have 40 minutes. That's because I'm watching the clock and I'm rounding in a bad way. Okay, let's keep it rolling. Can I get a volunteer to read the slide for me, please?
Many drugs used to lower high blood cholesterol levels are called, what does that say? Statins?
Yeah, I think
and
it's
are very
statins.
popular
Yeah.
and widely prescribed. Bioavailability is the amount of a drug you have ingested that makes it into your bloodstream.
Keep going.
A statin with a bioavailability of 30% has been prescribed for Boris. Boris is to take 20 milligrams of this statin every day. During the same day, 1/2 of the statin is filtered out of the body. Find the maximum concentration of the statin in the bloodstream on each of the first 10 days of using the drug and graph the result.
Okay. So it says a statin with a bioavailability of 30% has been prescribed. So what that means is that, for instance, if he takes a 20 milligram tablet, only 30% max will be available in his bloodstream at a time, right? So, for instance, if we let X be his days and Y be the amount of statin of the bioavailability. So, for instance, on the first day, he's going to have 30% of 20 is, I think, 6 milligrams. So if you do 0.3 times 20, the maximum concentration available in his blood is going to be 6 milligrams on the first day. Then on the second day, it takes 24 hours for it to what does it say? Only half the statin is going to be filtered out. So on the next day, half is going to be available plus an additional 60 because now he's going to take another 20 milligrams. So it's going to be 6 milligrams plus half of the previous. So half of the previous would be 3 plus the 6 to give him 9 milligrams available max concentration on day 2. Okay. So then on day 3, half of the previous will be what? 4.5 plus 6 is going to give us 10 milligrams available of bioavailability. Day 4, half of the previous is going to be 5.25 plus 6 is 11.25. And then day 5, I don't know, 125. Let me see. I can't think of this one. 5.5, 5.725, I think it is. I think it's 5.725 plus 6 is 11.725. That doesn't sound right. Maybe 11.725. It seems like it's leveling off. Like it's reaching a critical number. Because I'm definitely not about to cut that one in half. But we would keep going until we get to day 10. Right?
11.625.
Let's look at it. We got it. We actually have it here. So only reason I knew this is because I kind of worked earlier, so I can kind of walk you guys through it. So the formula that's kind of going on any given day is going to previous day's maximum concentration. Half of that's going to be available plus the 6 from he takes from that day. So this is the formula that I was using, right? So then again, so we have a chart here. On the first day, the max is going to be available is going to be 6 milligrams. On day 2, half of the previous plus an additional 6 is going to give us 9. If we continue, 11.625, I was close. I put 7. That should have been a 6. Go ahead and change that now. But then we can kind of keep going, right? 11.25, did we get that one at least? We did get that one, okay. And so we can go all the way until day 10. And then if we plot the points, we get an image that looks like this. So then the maximum concentration approaches about 12 milligrams. So if he takes 20 milligrams a day, with that formula, he approaches a maximum concentration of 12 milligrams. That's interesting. I never thought of it that way, though. Okay, let me see. Who is this? Oh, they were late. Dalen has been trying. Okay. I don't want him to be absent, so I'll tell him that I'm going to unlock the session. He needs to. Class starts at like today is what, Thursday? Class starts at 5:15, and then on Friday class starts at 5. Usually about 5 o'clock. I have the Zoom session open, so I'm going to tell him I'm going to open it up, and he can come in. But yeah, I'll mark him late for today. But usually at about 15-minute mark, I'll lock out the session. Okay, so just let him know that to join and to make sure he gets his attendance credit for today. because I don't want him racking up a whole bunch of absences. But we got to be here at the start of time. Okay. I'm starting to learn the nuances of this thing, so I'm going to start locking people out of my class, and I know that's going to start messing with the money. The best thing is try to get into my Zoom session early. Just indulge my games, or just make your presence known. Just get in there early. You can mute stuff. It's okay. Get in there early. Make your presence known, and we're going to work it that way. Okay. So that actually brought us to the end of, but yeah, just tell Mr. Land to go ahead and log in, and just make sure he gets his attendance credit today, so that we can at least set him as late and not as absent. Let's see. I want to add a page. Okay. Because I don't really want people racking up a whole bunch of absences. That's a bit much. Let's go to paper. Okay. Actually, like this is what I like. So now what I'd like to do, let's actually put this back. Does that change the view? Kind of. So now what I was thinking that we can do, the class, we still have about 30 minutes remaining. So I was thinking that we can go through some of the homework from Pearson. Right, so let me close out my earlier session. I'm going to close this one. I'm going to close this one. All right. So we're going to preview this. So we just finished out section 1.3. So we're just going to kind of work through some of my problem sets. And thank you for letting me know that he was trying to get in, because if you didn't say anything, I was just going to move on, and then that was going to be on his record. So, but hopefully we can get him in there. Just tell him to come on in. It's okay. Okay. We're going to let that stay like that. Okay. So we're going to play our game. I think we did this with this class, but so we have like 21 questions here, right? I'm going to ask Google for a random number 1 through 21. I think that Google is going to do, I don't know, I'm going to do 13. 13 is my number, right? Lucky number 13. Okay. Let's go for 10 seconds. Let me see. I'm going to start the timer. That sounds like Mr. Land. 10, 9, 8, 7, 6, 5, 4. Let me go to users. 3. Mr. Land, are you here now? Yes, I see you, Mr. Land. Okay. Okay, we're gonna close the thing. Oh my god. Close.
Sir,
Okay.
thank you. Thank you for letting me in.
Yeah, it's no worries. It's no worries. Just try to be here. Class.
Yes, sir,
Honestly, just log in about 5 o'clock. I know it's different
Yes, sir.
times.
I just had something come up at home today.
It's no worries. It's okay. But let me go ahead and update my attendance though, because if I don't do it now, so I close the thing. Let me go ahead and do the attendance. This is this. Okay, it's not showing there, which is what I want. Let's go to Blackboard. Anybody else on the call that didn't get attendance credit today? This is the lab itself. We're in the home stretch, guys. Let's go attendance. Come on. This is today. Okay, we're going to do it like this. Okay, that's fine. So I marked it as late. So it's not as bad as absent, because those absences are, they can mess up your money, honestly. But, you know, just as long as you're kind of checking in on a daily, you're here. And the main thing, yeah, that was a good move.
I got a question.
Hang tight. The main thing is that we're getting our assignment submitted on Pearson. That's the main thing. So we're making our presence known, and we're getting our assignment. We're getting our assignment submitted on Pearson. That's the main thing. That way, I have a record. I say, hey, they did their work. They were here for most of the sessions. You know, let's make sure that they're okay. Go ahead, Mr. Lamb.
Because I know you said absence did mess you up.
I think it's three of them total. Once you get into like the fourth one, then like we're allowed 3 unexcused absences, and then on the fourth one, then you know you could be automatically dropped and all this kind of stuff.
Right.
So just as okay.
I had an absence like 2 weeks ago on Friday.
Okay.
And I remember you said you'll go in and look at it or something like that.
Was that from the very first, like the second day of class?
Yes, sir. It was like the second day of class.
you had marked me absent.
Okay, let's look at it since we just did the other one. Because I know that second day, I think I had a meeting or something.
Like a 75 or something for attendance.
Yeah, I don't really want you guys to stress too much about attendance. Like the main thing is get our assignment submitted via Pearson. That's the main thing. There, and then just be present. Like I know you're coming in. You'd have to ask your classmates for how to check your attendance grade. Because it seems like you all know that better than I do. Attendance.
I just went to grades. Bro.
He said he went to grades.
Yeah, and then they had the attendance grade.
Let me see. But yeah, I don't want you stressing about that because I'm not really. You said the first shyster. This is week 3, so minus 14.
So it had to be. It was that Friday. So I guess the 22nd. I mean 21st.
The oldest one that looks like I have. Can I see all?
It was either 21st or the 24th.
Today, last week. Yeah, don't worry about that because all I have is the 25th, 27th, the 1st, and today. I know this is week 3, but.
Oh, okay.
Yeah.
All right, then.
Okay.
I guess I ain't gonna stress too much about it.
The main thing is just be here on a regular basis. Try to be here early.
Yes, sir.
And the main thing is getting our Pearson assignment submitted. Mr. Hamilton, are you here? Meeting. Let me go check this again. He's not here today. Okay. But yeah, that's the main thing. Okay. All right. Let me see the time. So if we get out at 6:30, no more than 20 minutes is what we need. Hey Siri, set a timer for 20 minutes. Okay.
Okay.
So
Your timer is set for 20 minutes.
Okay, let's see about this. Hey Google, give me a random number 1 through 21.
Here's a random number, 15.
15. Let's see. We got any 15ers? Oh, Mr. Squire got it. Celebration. Okay, he got it. 15. So again, if I was doing extra credit, we're just kind of practicing our intuition. How psychic are we? Just a little bit of fun. All right. All right, let's look at question number 15. All right, we don't need this. And we got some paper ready. And let's switch this view out. Oh, come on. View. You're going to start this? Okay, let's close you out. Close you out. Open you up. Hopefully we're not recording. I don't want it to record. But we are this one. And come on. View. Seamless. Okay, let's add a page right here. All right. Looking good. Awesome sauce. Okay. So I'm going to take some notes here. So this is homework. I don't know what I just typed. Homework. This is a homework session. This is from week 3. This comes from section 1.3 functions. We're about to go. Give me like 20 minutes and I'm going to take you out. Okay. 1.3 functions. And this is question number 15 from the homework. And it comes from section 1341. So that way I can find it later. It says use the, oh, I didn't even have to write nothing down for this one. Use the vertical line test to determine, is this a function, yay or nay?
No.
No, right? It fails the vertical line test. You can draw a vertical line. It touches it more than once, so it's not a function. Okay. Let me see. I'm going to hit open. Open. I'm going to go 20. I'm going to go 7 this time. So 7. I'm going to leave the polls open for 10 seconds. 8, 7, 6, 5, 4, 3, and 2. We're going to type close. Okay, let's see how do we do. All right, so starting from here. Hey, Google, give me a random number 1 through 21.
Here's a random number, 5.
5. Who got it? Open. Oh, do I see celebration? No. How do you know if it touches twice? Okay, I'll go back to that. Nobody got 5? Did I type close? Nobody got it. Oh, that sucks. Okay. We just did 15. So a question came in. How do we know if it touches twice, right? So looking at this graph, this question says use the vertical line test if it's to determine if this is a function. So notice we can draw a vertical line. It touches it once here and once there. So we just draw a vertical line, and if it touches it more than once. There's a request for 16. Okay, let's go ahead and do 16 since it was requested. Okay, 16. Answer the question about the following function. Okay, we got these, what? A, B, C, D, E, F. F is the last one. All right, we'll work through this one. I'm going to get a copy of this. So let me get a copy. I need from here. All I really need, I don't really need that. I'm going to go from here. This is all I need. Let me change that view though. Can I like go like this? Like this? I feel like that looks a little bit better. I feel like that'll be closer to my display style. So I want from here. This is what I want. And then I want to take this. Come on. There it is. And I want to share. Let's share. AirDrop. Okay, that's cool. I got it here. I'm going to hit done. I'm done with that. And let's hop back over here. Okay. And then let's make it a little bit bigger. We're going to let that stay at about that size. And then I'm going to load it here. So let's add a photo. I think it's this one, right? Just that last one. Insert the photo. Yes, this is right. And, oh, you're slowing down again? Come on. All right. Hang on. Let me just close you out. Hopefully you back. Yeah, that looks better. Insert the photo. Whoa. Undo. View is seamless. Alright. I'm going to expand this to like this. Boom. That looks better. Oh, it's blurry. No. Why are you blurry? Hey, there's no reason for you to be blurry. That totally hurts my eyes too. Alright, well we can use it. I know it's blurry. I can't do this. I'm gonna get another one. Hang on. Oh, I don't feel like doing all that. I'm not gonna do it again. I'm gonna just use it as a reference. Okay. So let's hop over to the iPad. Just for the sake of time, I'm gonna go with it, even though it's blurry, but I'll rewrite everything. Or the pertinent things. So again, the original function, so f of x, let me see something. It's fine. It's gonna be 4x squared minus x minus 3, right? So then part A asks, is the point -1, 2 on the graph, right? So then what that means, when basically it's saying when x is -1, is y 2. So we're going to say 4 times -1 squared minus -1 minus 3. That's the first one's going to be 4 plus 1 minus 3. 5 minus 3 is indeed 2, so that one checks out. So A, we would say yes. Okay, let's go on to B before we submit our answers. If x equals 2, what's the y? What point is on the graph, okay? So then basically it's saying find f of 2. That's 4 times 2 squared minus 2 minus 3. That's going to be 4 times 4 is 16 minus 5 is 11. So then the point on the graph is going to be 2, 11 for this one. Okay, I'm going to go with that one. And then C says, if f of x equals -3, what's x? What point or points are on the graph? So if we let y be -3, so then for C we're going to do 4x squared minus x minus 3. I think we said let y be -11. Sorry, this is C, right? For C, let y be -3. Okay? So then if we solve, if I add 3 to both sides, I think they're gonna cancel each other out. This is gonna be canceled by that. So then, on the right we would have 0. On the left, we're gonna have this 4x squared minus x. Notice it's already equal to 0. So we have a greatest common factor. So we want to factor out the greatest common factor. In this case, they both have x. If we factor out an x, we're left with 4x minus 1. Now we use what's called the zero factor property. When things multiply to give us 0, basically set each thing to 0 and solve. Okay? So if we add, the first one is done for us, add and divide, x equals 1 by 4. Okay? So for part C, what points are on the graph? So then we have 0, comma, -3, and the other one is 1/4, comma, -3. And we'll check these before we submit our answers to minimize the chance of us making a mistake. And let me be a little bit consistent here, get rid of that. Let me be consistent. Let me get rid of this. Be consistent. Okay, that was what, part C. It says, what's the domain? Okay, we got this. Let me get a copy of the original, which is this guy. Let's copy. Paste. This is part D. The domain. So, can somebody tell me? Well, I'll just, because we still got about 10 minutes. Can anybody tell me what kind of shape this graph is going to make? The highest exponent is a 2.
Parabola.
It's a parabola. It's going to be a U-shaped curve. What does this -3 tell us?
The y-intercept.
What does this positive leading coefficient tell us?
And it's stretching.
Okay, but which way does it open?
Up.
It opens up, right? So we got a U-shaped graph that has a y-intercept of -3 and it opens upward. Okay, so if we have a U-shaped graph, what's the domain of a parabola? What's the very left to the very right?
Negative infinity.
Right, so the domain in this case is going to be all rails. Okay.
Excuse me, Professor.
Go ahead.
I'm about to leave, so I'm about to join the Zoom call off my phone. Is that okay?
Of your what?
Off my phone.
Oh, yeah, it's fine.
All right.
Let me see. Yeah, just be back. Let me go to security, make sure this thing is open. Okay, it should be open. Okay, let's see. On style, like this. That was D. Let's look at E. It says list the X-intercepts and part F are any Y-intercepts, okay? So then E, the X-intercepts, again, to find this, we're going to set Y equal to 0. So that means we're going to have 4x squared minus x minus 3 equal to 0. Okay, so we need to factor this. So I'm going to do this one a little bit different than how we've been doing it. We're looking for two numbers that multiply to give us what in this case? Two numbers that multiply to give us what?
-3.
So I would agree if the leading coefficient were a 1. But because of that 4, we're actually looking for two numbers that multiply to give us a -12.
Yeah.
Right. So that's I call it the AC method. So two numbers that multiply to give us -12. Now, really quickly, 12 is what? 4 times 3. So that's going to be 2 times 2 times 3. Okay? So I'm doing this on purpose this way so you can see a methodical way of getting through all the options so we're not guessing and checking, right? So we're gonna go through all the factors until we get to the line that adds up to, let's change this color to like blue. Until we get to the line that adds up to the -1, right? Okay. So first we have -1 and 12, but that adds up to 11, so that's no good. We got -2. Now look, if we use this -2, what's left over is 6, right? So if we use the 2, we have 6, and those add up to 4, so that's no good. Can we do 3? Yeah, we can do 3. If we use this 3, what's left over is 4. Right? Notice those add up to positive 1, but we want negative 1. So we're going to do 3 and negative 4. Right? So then the next part, I'd like to do the following. I know you guys had a X method. I'm going to use this box method. Right? Let me do style. Let's make it thicker. I want to copy, paste. You need to go like here. You need to go like here. Okay. Maybe a little bit lower. Looks weird. Okay, we'll go like this, right? So I'm using this what's called the box method. Let me paste again. And let me put you about here. That looks better. And then you about, we got 2 left over there. And that looks good. Okay? This is what we're going to use. So now in the upper left hand corner goes the 4x squared. The bottom right hand corner we're going to do the negative 3. And then we're going to rewrite that blue x using the numbers that we found. Right? So I'm going to match the colors. Right? So we're going to rewrite that blue x using the numbers that we just found. So we're going to have a positive 3x and we're going to have a negative 4x. Okay? Because 3 plus negative 4 is negative 1, right? So now, what do the top 2 have in common? Oh, wait a minute. Let me do... I mean, this is fine, but let me just move it real quick. I want to move this like this way. Let me move all of this.
Do we have to use that? Because that looks confusing.
No, you don't have to do this. Let me do it like this. And then let me move you out of the way. It's all getting jumbled. Let me go here. Okay, hang on. Let me back up. Back up. Let me see. Let me just move this out of the way. Move this out of the way. And all of this is what I want to move over. That's better. And then you go like there. And you go like this. Okay. So now, let's keep going. So again, the upper left-hand corner was the black. Bottom left was the constant. And then the off diagonal were the 2 numbers that we just found. So now, heck, I keep doing it wrong. Sorry, hang on. I'm going to move you. It's these 3. Move you down. And I think that's good there. I think we're good to go now. Okay. So what do the top 2 have in common? What can we factor out of these 2? What's the greatest pardon?
X.
X. They both have an X, right? So they both have X. What do the bottom 2 have in common?
Negative 1.
We can factor out a negative 1 from both of those. What do the left 2 have in common?
4.
And what else?
4x.
So we can factor out a 4x from both of those. And what do the right 2 have in common?
Just 3.
Just a 3, right? So then ultimately we're saying that the original factors into 4x plus 3 times x minus 1. Okay? I know I kind of had my lines a little bit weird. I was just moving the lines over, being nitpicky for no reason. But that's the gist of how that one goes, right? Without that line thing, it would have been a lot smoother. Okay, and so we can check this, right? 4x times x is x squared. Outer is 4x. That's going to be a negative 4x. This is going to be a plus 3x. And so they indeed add up to this. And then 3 times negative 1 is negative 3. Okay? So that worked out. So now we got things that multiply to give us 0. I'm going to just pick it back up here. And I'm probably going to go, like Amy Winehouse, I'm going to go back to black. So when things multiply to give us 0, I see the time. We're going to say 4x plus 3 equals 0 or x minus 1 equals 0. Okay, if we solve each one, subtract and divide, x equals negative 3 by 4 or x equals 1. And let's put it in context. These are the intercepts. So then we got negative 3 by 4 comma 0. And we got 1 comma 0. Okay. And then the last one is actually really quick. F, the y-intercept. Let me get a copy of this guy right here. Copy. Paste. Style. And I want it all to be black. For the y-intercept, we just set x to 0. So we're going to do f of 0. That's going to be 4 times 0 squared minus 0 minus 3. Again, this goes to 0, this goes to 0, and your answer's right there. So then the y-intercept is going to be 0 comma negative 3. Okay, let's check our results. Style, let's go thick, and I want to copy that. Copy. Oh no. Let's just paste. And we want this. Oh, come on. Okay. We want you to cover these guys. Okay, let's check this and we're going to close out. Okay, let's check these results. So, okay. So I'm going to use my calculator. Come on. This one. It's looking good. Let's reload and refresh. Let's get rid of this paper. Let's get rid of that. All right. I know. Thank you. Thank you. Let's see. Come on. That looks good. Okay. So we're going to go to y equals. The original is clear. Let's go to 4x squared minus x minus 3. I'm going to quit. Y variables, number 1 and 1. So now, for instance, is negative 1, 2 on the graph? So when x is negative 1, the output should be 2. We got a yes there. B, if x is 2, so let's recall and let x be 2. When x is 2, we said that y was 11. We got that one, okay? For part C, we said when x was 0 and 1/4. So when x is 0, we should get negative 3, and when x is 1/4, 1 by 4, we should get a negative 3. Those both worked. What's the domain? All rails is a polynomial. The x-intercepts, so the x-intercepts we already confirmed one of them. Let's just do it again. The first one was, did we do something wrong? Negative 3 by 4. Okay, and then the next one was 1. So I'm gonna get rid of all this and just type 1. Okay, those both work. And then the y-intercept, if we set x to 0, that's the one that we did already. It was a negative 3. Okay, so we confirm these answers. So then what I'm gonna do, this is the last thing, and then we'll open the floor for questions and let everybody go. Let my people go. Yeah, that's totally me. Are you still working? Come on. What's going on here? You're acting frozen. Come on. Uh-oh. Do I have any other? I don't have any other. Oh, we might have to just go with it. Oh, got the spinning wheel of frozenness. So I think I'm low on space. I think I have, when I'm streaming, it's recording, and I gotta delete those recordings. I gotta go and find them. Okay, so we're just gonna go with this for now because my thing is frozen right now. So I'm not gonna worry about it. I'm gonna hide this, or try to hide it. I'm gonna hide this one. I just wanna hide everything, really. Okay, it's totally, there you go. Come on, and you're still gonna act like that. I'm just gonna force quit you. Yeah, that's fine. We can force quit. Okay. Let's go back. I like that background. And okay. So we're gonna have to go with our answers because it locked up on us. Did anybody have any questions before I let everybody go? Anybody have any questions? Okay, if there aren't any burning questions, I'm gonna let everybody go. You guys are awesome. Tomorrow class starts at 5, so just try to be in here, and we'll do the best we can. Okay. All right, guys. Take care. I'll see you tomorrow. This is up, 8 down. Peace.
Alrighty.
Take care.